Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, you're going to learn how to determine the measures of these two missing angles, measure of angle DFE and measure of angle DGB, using circle theorems in relation to where the intersection of two secants or two chords happens. This is the given figure. As you can see, we have two secants intersecting at a point outside the circle at point C. The measure of the angle formed by the two secants is given. It's equal to 42 degrees. We also have two chords intersecting inside the circle. One of the angles formed by the two intersecting chords is unknown. We are going to look for the measure of angle DGB. This is angle DGB. Remember that when naming an angle using three letters, the middle letter is the vertex of the angle. The other two letters are points on each side of the angle. We are required to use three letters in naming an angle when there are more than two segments extending from a point. Next, we also have two chords intersecting on the circumference of the circle. And the angle formed by two chords intersecting on the circumference of the circle is called the inscribed angle. So we have inscribed angle BEF. Its measure is known. It's equal to 26 degrees. We also have inscribed angle DFE, and this is one of the indicated angles in the problem. We also need to look for the measure of angle DFE. Let's begin our solution by considering chords intersecting on the circumference of a circle. Look at chords BE and FE. The chords intersect at point E, which is on the circumference of the circle. The angle formed by the chords intersecting at point E is an inscribed angle. What is an inscribed angle? An inscribed angle can be defined as an angle formed by chords intersecting at a point on the circumference of a circle. Therefore, angle BEF satisfies the definition of an inscribed angle. I have drawn inscribed angle BEF separately. This is the figure. Arc BF is the intercepted arc of angle BEF. What is an intercepted arc? An intercepted arc is an arc enclosed by the chords that cut across the circle. It's inside the inscribed angle and its endpoints are on the sides of the inscribed angle. Therefore, arc BF satisfies all the descriptions for an intercepted arc. Now that we have identified inscribed angle BEF and its intercepted arc BF, we can solve for the measure of arc BF by applying the inscribed angle theorem. This theorem tells us that the measure of an inscribed angle is 1/2 of the measure of its intercepted arc. Let's apply the theorem in writing our equation. Measure of angle BEF is equal to 1/2 the measure of its intercepted arc BF. To solve for the measure of arc BF, let's replace measure of angle BEF with its known value. It's equal to 26 degrees. We now have 26 degrees equals measure of arc BF divided by 2. To solve for the measure of arc BF, we need to isolate it on the right side of the equation. We're going to use the multiplication property of equality to isolate measure of arc BF on the right side. Let's multiply both sides of the equation by 2. This will cancel out the denominator on the right side of the equation. Therefore, measure of arc BF is isolated on the right side. Find the product on the left side. 2 times 26 equals 52 degrees. This is the measure of arc BF. We get 52 degrees. For the second part of our solution, let's focus on two secants intersecting outside a circle. Refer back to the given figure. We have secants DC and EC intersecting at point C, which is outside the circle. I have drawn the two intersecting secants separately. Let's refer to this figure. The angle formed by the two intersecting secants is angle DCE or angle C. Remember that we can also name an angle using vertex only if there are only two segments extending from a point. The special name for this angle is exterior secant angle. Exterior because it is formed outside the circle. Secant because its sides are secants of the circle. Notice that the exterior secant angle DCE has two intercepted arcs. We have arcs BF and DE. We can call arc BF as the nearest arc or the smaller arc. And we can call arc DE as the furthest arc or the larger arc. The measure of the exterior secant angle DCE is given. It's equal to 42 degrees. The measure of arc BF, which is the nearest arc of angle DCE, is equal to 52 degrees. This is the value that we have obtained from the first part of our solution. The measure of arc DE, which is the furthest arc of angle DCE, is unknown. We can solve this using the exterior secant angle theorem. This theorem tells us that the measure of the exterior secant angle is equal to 1/2 times the difference between the measures of the furthest and the nearest arcs. Let's apply the theorem in writing our equation. Measure of angle DCE equals 1/2 times the difference between the measure of arc DE and the measure of arc BF. Angle DCE is the exterior secant angle. Arc DE is the furthest arc. Arc BF is the nearest arc. Replace left side with its known value. It's equal to 42 degrees. Replace measure of arc BF with 52. It's also known. We now have an equation 42 equals 1/2 times the difference between measure of arc DE minus 52. Our goal is to solve the value of measure of arc DE. In order to solve for measure of arc DE, we should be able to isolate it on the right side of the equation. So step 1, let's use multiplication property of equality. Multiply both sides by 2 to clear the denominator on the right side of the equation. This will cancel the denominator on the right side. The right side becomes measure of arc DE minus 52. The left side becomes the product of 2 and 42, which is equal to 84. To eliminate the minus 52 on the right side, let's use the addition property of equality. Add 52 to both sides of the equation to cancel out minus 52 on the right side. The right side becomes measure of arc DE. This is our goal, to be able to write measure of arc DE on its own. Left side is the sum of 84 and 52. 84 plus 52 is equal to 136. This is the measure of the furthest arc of the exterior secant angle DCE. Since we already know the measure of arc DE, we are now ready to find the measure of the indicated angles. This is our main problem. We need to find the measure of angle DFE and measure of angle DGB. Let's concentrate on the first indicated angle. Measure of angle DFE. This is the angle. F is the vertex, D and E are points on each side of the angle. I have drawn angle DFE separately. Let's refer to this figure. As you can see, angle DFE is an inscribed angle. Its intercepted arc is arc DE. Like in part 1 of our solution, we can use the inscribed angle theorem. Again, the inscribed angle theorem tells us that the measure of an inscribed angle is equal to 1/2 of the measure of its intercepted arc. Let's write our equation. Measure of angle DFE equals measure of arc DE divided by 2. This equation is an application of the inscribed angle theorem. Measure of angle DFE is unknown. Measure of arc DE is equal to 136. Let's replace it with its known value. So we now have measure of angle DFE equals 136 divided by 2. And 136 divided by 2 is equal to 68 degrees. Therefore, measure of angle DFE is equal to 68 degrees. We have solved one of the two indicated angles. For the final part of our solution, we are going to consider two chords intersecting inside a circle. Refer back to the given figure. We have chords BE and DF intersecting at a point inside the circle, at point G. The angles formed by the two intersecting chords inside the circle are called inscribed angles. So, we have another definition for an inscribed angle. An inscribed angle can also be defined as an angle whose vertex is inside the circle. One of the indicated angles is angle DGB. It is an inscribed angle whose vertex is inside the circle. Let's draw the intersecting chords separately. Refer to this figure. Chords BE and DF intersect at point G. This is angle BGD. We need to look for the measure of angle BGD. How are we going to solve for the measure of an inscribed angle whose vertex is inside a circle? We are going to apply the interior case of inscribed angle theorem. What does the interior case of inscribed angle theorem tell us? The interior case of inscribed angle theorem tells us that the measure of an inscribed angle whose vertex is inside a circle is equal to 1/2 of the sum of the measures of its intercepted arcs. Let's focus on the indicated angle. Angle DGB. G is the middle letter. This is the vertex of the angle. The other two letters are points on each side of the angle. Therefore, this is the indicated angle. The intercepted arcs of angle DGB are arcs BD and FE. By application of the interior case of inscribed angle theorem, this is our equation. Measure of angle BGD equals 1/2 times the sum of the measures of arc BD and arc FE. This is the inscribed angle whose vertex is inside the circle. These are the intercepted arcs of angle BGD or angle DGB. Remember that you can interchange the two letters at the left and right of the vertex G. But we don't know the measure of arc BD and arc FE. So how are we going to solve for the measure of angle BGD? Notice that the circle is divided into 4 smaller arcs. We have arcs BF, FE, ED, and DB. Remember that you can interchange the letters when naming an arc. If we add up the 4 smaller arcs, the sum is equal to 360 degrees. Replace measure of arc BF with 52 degrees. Replace measure of arc ED with 136 degrees. Combining the two measures, 52 plus 136 is equal to 188 degrees. The left side becomes 188 plus measure of arc FE plus measure of arc BD. And this is equal to 360 degrees. We need to isolate this sum. So how are we going to isolate this sum? Use addition property of equality. Add negative 188 to both sides of the equation to cancel out the positive 188 on the left side. Therefore, the sum of the measures of arc FE and arc BD is equal to 360 plus negative 188 degrees. 360 plus negative 188 degrees is equal to 172 degrees. We are going to use this into this equation. By commutative property of addition, interchanging the order of the addends will not affect the sum. Therefore, measure of arc FE plus measure of arc BD is also the same as measure of arc BD plus measure of arc FE. So we are going to replace this with 172 degrees. We are now ready to solve for the indicated angle. Measure of angle BGD equals 1/2 times 172 degrees. What is 1/2 of 172 degrees? It's equal to 86 degrees. Remember that when naming an angle using 3 letters, we can interchange the outside letters. Angle BGD is the same as angle DGB. We have computed for the value of the second indicated angle. Measure of angle DGB equals 86 degrees. Okay, we are done with our problems. We are able to find the measures of the missing angles. Measure of angle DF equals 68 degrees. Measure of angle DGB equals 86 degrees. If you have any questions or you want further clarification, please feel free to post your comment. Don't forget to subscribe to my YouTube channel, Tutor Marife MCP. Thank you for watching.